Okay, in this video we're going to take a look at graphing some circles. So you may or may not remember or have learned about equations of circles in geometry class, but if you don't, that's okay because we're going to review it here. So um, I have here an equation, x squared plus y squared equals 25. Okay, now you might recognize that as looking very similar to the Pythagorean theorem, and in fact you would be correct because the equation of a circle is actually just the Pythagorean theorem, which will kind of make sense here after we look at the graph here in a minute. Um, Now there is a standard form for equations of circles which goes like this. So the standard form for an equation of a circle in a coordinate plane is um, x minus h squared plus y minus k squared equals r squared. Okay, so you might be wondering, well, what does all that mean? So basically, h and k, that's the coordinates of the center of the circle. So if you have h, k, that is the center of the circle. And the r variable is the radius of the circle. Okay, now you might be wondering, why do they use h and k for the center? I don't know, they just do. Most math books you'll see actually do use h and k, so it's relatively standard. But yeah, if you have an equation in this form, that tells you how to graph the circle basically. So this equation, you might say, well, isn't it missing the h and the k? It's just x squared plus y squared equals 25. And you're sort of right in that it doesn't look like there's an h and k there, but that basically just means that h and k are both 0. So in this case, the circle is centered at 0, 0. So in this case, h is 0 and k is 0. So it's centered at 0, 0. And then the radius, notice how in the standard form of the equation, r squared. So where the r squared is 25. So if r squared is 25, what does that make r? Well, that makes r 5 because the square root of 25 is 5. So what I have is a circle that is centered at 0, 0 with a radius of 5. Okay, so I'm just going to go ahead and, so if the radius is 5, that means I'm going to just graph a few points here that are 5 spots away from the center. It's easy to count if you just look at on the x and y axes. So my circle should go through all 4 of those points because each of these is 5 units away from the center here. Now if I want to get really fancy and draw a really good circle, I would grab a compass, but I'm not going to get that fancy, so I'm just going to kind of sketch in a quick circle. And that's okay, not the best circle I've ever drawn, but especially this part over here, but you get the idea. So here is a circle. It's centered at 0, 0, has a radius of 5. Okay. Now you might be wondering, well, what does this have to do with the Pythagorean theorem? Well, basically, picture if you pick any point on the outside of this circle, any point on the outside of this circle, if you plug in the x and the y, it would fit this equation here. Like if I just pick some random point over here, if I was to draw in a right triangle, I've got the x coordinate and the y coordinate, and the hypotenuse is the radius of the circle. So that's why the equation of a circle is nothing more than the Pythagorean theorem. Now we're going to use this equation of a circle a little bit in once we get to the actual trigonometry part of trig class, which starts in chapter 4. So that's kind of why we're reviewing it now. All right, so let's look down here. So here I've got another equation, which says graph the equation x minus 2 squared plus y plus 4 squared equals 9. So remember, once again, a standard form of the equation is x minus h squared plus y minus k squared equals r squared. So in this case, you can look at the equation as it's written and you can identify the h and the k and the r. So the h is actually going to be 2 and the k is actually going to be -4. So be careful, because whatever the signs are in the equation, it's kind of opposite down here because of this minus here. So if you plug in -4 for k, you'll get y minus -4 or y plus 4. And if you plug in 2 to here, you'll get x minus 2. So it all fits in. And then what about my r? So r squared is 9. So if r squared is 9, that means your r is 3. So just be careful with this. So the radius isn't 9, the radius is 3. Okay, so that means my radius is 3, and the center of my circle is at the point 2, -4. So given those two facts, that the center is at 2, -4, and the radius is 3, you can go ahead and graph your circle. So 2, -4, I'm going to go back 2, down 1, 2, 3, 4. Okay, so that's the center of my circle, and then the radius is 3, so I'm just going to, easiest way to kind of sketch a quick graph is to count over 3 spaces, and count up 3 spaces, left 3 spaces, and down 3 spaces. So there's kind of some points on my circle, and so now I'm just going to sketch in a circle that goes through those 4 points here. So once again, I didn't do the best job because I didn't use a compass. Trying to fix a little bit. You might even say I did a bad job, but it's good enough for a quick sketch. Alright, so last thing I'm going to do here is kind of do the same, sort of the same thing, but opposite. So this says write an equation of a circle that's centered at the point 10, -3, and has a radius of square root of 12. So if, once again, I'll write it one more time so you can see it. The equation of a circle is x minus h squared plus y minus k squared equals r squared. So the center is hk and the radius is r. So all I'm going to do is basically plug in these points in the right spot and I'll be done. This is a pretty quick question actually. So h in this case is 10. So I'm going to put x minus 10 squared. K in this case is -3, so I'm going to put y minus -3 squared. And then r is square root of 12, so I'm going to equal square root of 12 squared. Okay, now I can simplify this a little bit. So x minus 10 squared, I can't really simplify that, so I'm just going to leave that as x minus 10 squared. Y minus -3, minus a negative is just plus a positive, so I'm going to go ahead and put y plus 3 squared. And then square root of 12 squared, square root of 12 squared is just 12. And so that is it. So if you're given the center of a circle and its radius, you can pretty easily just put it into the standard form of a circle equation.